Hello pre-calculus students, and welcome to a video on the sum and difference formulas for trig. And we're going to be developing this is an introduction, so the first of many. We're only going to develop one formula and then we're going to look at applying them. But there's 4 formulas altogether and we're going to see one of them right now. Okay, so what we need is the distance formula. We need the definition of the sine and cosine. So that's basically that, just to remember that the cosine of an angle is x over the radius, and that the sine of an angle is y over the radius. And when we're looking at the unit circle and the radius is 1, then this simplifies to x equals the cosine of theta, whatever angle theta may be, and y equals the sine of the angle. Okay, and then the last thing is just to sort of remember that an angle in standard position is sitting here on the with the positive x-axis as part of the angle, and the other part, the terminal side, somewhere else. Okay, so we're going to look at angles inside the first quadrant, and we're going to combine these facts together to come up with a nice little identity. Okay, so here what I've drawn, and let's just focus on the circle on the left first. Okay, so I've drawn a circle that has 3 different angles. 2 of them are in standard position, namely the smaller angle B here, that's in standard position. And so for this little angle here, the point on the unit circle, and this is the unit circle, so we're going to say that this is just a radius of 1. The cosine would just be the cosine of the angle, comma, sine of angle. That would be the x and the y. We also have drawn here a larger angle, which is beta. Now, by the way, just these alpha is just the Greek letter for A, alpha, and beta looks like a B is the Greek letter for beta, just so you have a little point of reference for these Greek letters. Okay, so we've got the larger angle alpha here, and that means that if you take that angle and you take a point on the unit circle, that the x-coordinate would be the cosine of alpha and the y-coordinate would be the sine of alpha. Now, most importantly, what we have here is a third angle that is not in standard position. And that angle is this smaller angle from here to here. And that angle is actually shown right here in black, and that's alpha minus beta. It's the larger angle alpha minus the smaller angle, so that's the angle alpha minus beta. It's not in standard position, but it's still based on 2 angles that are in standard position. Okay, so what I've done in the second circle is I've just simply drawn this angle right here, the alpha minus beta, but I've drawn it in standard position. So there's the same angle with the same measure in standard position. And if this is the same size circle and it's the same size angle, then I hope you would agree that the distance here from this point here, from this point, these 2 points here, this segment is the same. I'll just do this like this is the same length as this segment right here. So that's where we're going to apply the distance formula by basically saying those 2 things are the same and then simplifying. So basically, just to clarify, this angle here is alpha minus beta. It's the same measure as this alpha minus beta here. And so this x-coordinate here, now this is an ordered pair, so this should be in ordered pair notation. So there's an ordered pair. There's the x-coordinate is the cosine of alpha minus beta, and the y-coordinate is the sine of alpha minus beta. Okay, now if we name these red points P1, P2, P3, and P4, as you can see, they have to be equal, so the distance from P1 to P2 would have to equal the distance from P3 to P4. Now I'm just going to write that down here using the distance formula. So on the left side, I'm going to do it from the first circle. So remember, using the distance formula, it's the difference in the x's squared plus the difference in the y's squared. So the difference in the x's squared, cosine of alpha minus cosine of beta, squared, plus the difference in the y's, which is the sine of alpha minus the sine of beta squared. And that is the same length as P3, P4, so coming from over here, the difference in the alphas would be the cosine of alpha minus beta minus 1 squared, plus the difference in the y's would be the sine of alpha minus beta minus, that's a parenthesis, minus 0 squared. Okay, now what we're going to do, and I'm going to pause it and ask you guys to try to simplify this a little bit. Simplifying requires first expanding. So what we're going to do is we're going to square both sides, and then we're going to expand the 4 binomials. So we're going to expand this one by multiplying cosine of alpha minus cosine of beta times itself, and then do the same thing with this one, and this will be a little bit simpler because it's minus 0. Okay, so you try it, and then we'll compare at the end. Okay, so I've expanded the 4 binomials, and just to make sure that it's clear, this one leads to these 3 terms. Okay, and this binomial leads to these 3 terms. And so the top row is just the left side of the equal sign. And then this binomial leads to these 3 terms. And then this binomial, because it's minus 0, it's just another way of saying sine squared of alpha minus beta, so it leads to that. Okay, now the fun part. We get to contract this, make it use the Pythagorean identities, make it a lot smaller and simpler. It doesn't get to a monomial or a single term, but it does get quite a bit simpler. Okay, so the first thing that I see, and you guys can look around, you might want to pause this and see what you can see that can cancel here. But actually, let me do this. Look for 3 Pythagorean identities. It's going to occur 3 times, create 3 different ones in 3 different places in here. So I'm going to suggest that you guys pause it and look for that. Okay, so here they are. So the first one is the cosine squared of alpha plus the sine squared of alpha. That's 1. So we've got 1. The second one is the cosine squared of beta plus the sine squared of beta, and that's also 1. These next 2 are not quite the same. This is minus 2 cosine of alpha, cosine of beta, and this is minus 2 sine alpha, sine beta. So we can't really, they're not like terms. We can't just get rid of them. So I'm just going to write them both down. 2 cosine alpha, cosine beta, minus 2 sine alpha, sine beta. Now let's look at the bottom. Now here's the third occurrence of the Pythagorean identity. Right here, there's the cosine squared of alpha minus beta plus the sine squared of alpha minus beta, and that's 1. Okay, there's another 1 right there, so let's add that 1. And then we've got minus 2 times the cosine of alpha minus beta. Okay, this is getting close. Now we can subtract away these 1s. We can multiply everything by -1, or you just think of also as adding this to one side and adding all these to the other, but we're going to end up with 2 cosine of alpha minus beta equals 2 cosine alpha cosine beta plus, because we multiplied by -2, we moved them around, plus 2 sine of alpha sine of beta. Divide everything by 2 and we get the cosine of alpha minus beta is equal to the cosine of alpha cosine of beta plus sine of alpha sine of beta. Now even if we were in class and not doing this remotely, I would allow you to use the formula sheets. I don't make you memorize these, but let's look at the identity paper now. Here's the identity. Here's the identity page, and here's the sum and difference formulas right here, and this is the one that we just found, the cosine of alpha minus beta. So look at that, look back at what we just found, and it should look like the same thing. Okay, so that's an introduction to where these sum and difference formulas come from. Next video will show how to apply them. I hope you found this video helpful.